This lesson covers the binomial theorem. For non-zero real numbers a and b, a plus b to the power of n equals the sum from j equals 0 to n of n choose j times a raised to the power n minus j times b raised to the power j for all natural numbers n. Let's expand x plus 2 to the fourth using the binomial theorem. Here we can see that a will be x, b will be 2, and n will be 4. So let's go ahead and expand. We'll have the sum from j equals 0 to 4 of 4 choose j times x raised to the power 4 minus j times 2 raised to the power j. Our first term will have a j value of 0. So it will be 4 choose 0 times x raised to the power 4 minus 0 times 2 raised to the power of 0. We'll have plus our second term. The second term will have a j value of 1. The third term will have a j value of 2. The fourth term will have a j value of 3. And the fifth term will have a j value of 4, our upper limit. So that will be the last term. We'll simplify. 4 choose 0 is 1. 4 choose 1 is 4. 4 choose 2 is 6. 4 choose 3 is 4. 4 choose 4 is 1. 2 raised to the power of 0 is 1. 2 raised to the power of 1 is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth is 16. And after simplifying further, we have the expanded binomial x to the fourth plus 8x cubed plus 24x squared plus 32x plus 16. Let's find a single term in this next expanded binomial. Let's find the third term of 3x minus 2 raised to the power of 6 using the binomial theorem. And so here I can write 3x minus 2 to the 6th as 3x in parentheses plus negative 2 in parentheses, then raised to the 6th power. That helps me to see here that a will be 3x, b will be negative 2, and n will be 6. So if we expanded, we would have the sum from j equals 0 to 6 of 6 choose j times 3x raised to the power 6 minus j times negative 2 raised to the power j. However, we don't want to do the full expansion here. We only are looking for a single term. So we will find 6 choose j times 3x raised to the power 6 minus j times negative 2 raised to the power of j. For only the third term, what will the j value be there? Well, for the third term, j will equal 2. For the first term, j will be 0. For the second term, j will be 1. And so for the third term, j will be equal to 2. So plugging in a j value of 2, we have 6 choose 2 times 3x raised to the power 6 minus 2 times negative 2 raised to the power 2. This will be equal to 6 choose 2 is 15. We'll have 3 raised to the fourth times x raised to the fourth, and then negative 2 squared is 4. Simplifying, we get 4,860 times x to the fourth. So you can see this would have gotten ugly, expanding the whole binomial just to find that one single term. Try on your own. Use the binomial theorem to find the second term of 2x minus 1 raised to the power 4.